Dear students, in this video I will solve a problem of capacitor, and this is a problem of National Standard Education of Physics 2022. And before starting this problem, I will explain about the capacitor, as this problem depends upon the capacitor, chapter capacitor. We know that suppose there are two capacitors C1 and C2 which are in series, then total capacity of the capacitor, it should be C1 C2 upon C1 plus C2, or we can say 1 upon C equal to 1 upon C1 plus 1 upon C2. And in this case, if capacitors are in series, then charge on both the capacitors remain same. And if capacitors C1 and capacitors C2 are in parallel, suppose a battery is connected in this capacitor, then potential difference, suppose potential difference of the battery is V, then potential difference of both capacitors remains same, as these two capacitors are in parallel, but charge in both capacitors remain different. So this is the concept which we used in to solve this problem, and now we solve this problem. And the problem is a system of capacitors C1 4 microfarad. This capacitor is of 4 microfarad. C2, this is C2, this is 1 microfarad. And C3, this is C3, this is 2 microfarad, and C4, this is 3 microfarad. Connected across a battery, this is a battery, and potential difference of this battery is 15 volt. A battery of EMF E 15 volt as shown in figure. The change that will flow through the switch K when it is closed. If we close this key, this is a key, if when it is closed, then there are four options: 15 microcoulomb C2D, 12 microcoulomb C2D, 6 microcoulomb D2C, and 9 microcoulomb D2C. Now it means if we close this key, it means the circuit becomes like that. This is a capacitor. This circuit becomes closed. This is a capacitor. This is 4 microfarad. This is 1 microfarad. And now this is 2 microfarad. And this is 3 microfarad. It is closed. If key is closed, it means in this situation, suppose this is battery of 15 volt, and in this situation this 4 microfarad and 2 microfarad are in parallel, and in case of parallel, C becomes C1 plus C2. It means after connected 4 and 2 in parallel, suppose it becomes C5. C5 becomes 4 plus 2, 6 microfarad. And again 2 and 3 become parallel. Suppose this is C6, 1 plus 3, 4 microfarad. This is 6 microfarad and this is 4 microfarad. And now the circuit becomes, this is C5, this is C5, this is C6, C6 is 4 microfarad and C5 is 6 microfarad. And these two capacitors are connected with a battery of 15 volt. This is 15 volt. Now these two capacitors are in series, then total capacity, it should be equal to C5 into C6 upon C5 plus C6, or we can say 6 into 4 upon 6 plus 4, this is 24 upon 10, or we can say 2.4 microfarad. The total capacity in this situation, this is 2.4, this is 2.4 microfarad. And we know that total potential which is connected with the circuit is 15 volt, and charge flow, we know that Q is equal to C into V. Total capacity is 2.4, potential difference is 15 volt, and it becomes 15 into 2, 30, 36 microcoulomb. The value of this is in micro, so that charge becomes 36 microcoulomb. And if total charge 36 microcoulomb, it means charge on in C5 is 36 microcoulomb, and in C6 again 36 microcoulomb. So potential difference across C5, suppose this is V1, it should be Q upon C5. Q means 36 and C5 means 6. This is 6 volt. Potential difference against across C5, this is 6 volt. And suppose V2 is the potential difference across the C6, and we can say this is Q upon C6, and Q is 36 and C6 is 4, and we can say it 9 volt. So 6 across C5 potential difference is 6 volt, and across C6 potential difference is 9 volt. So we can say that in this circuit, potential difference across 4 microfarad and 2 microfarad, it should be 6 volt. It should be 6 volt. As potential difference in parallel remains same as we have already explained. So 6 volt is the potential difference between 4 microfarad and 2 microfarad. So now we can calculate the charge across the plates of 4 microfarad, and it should be Q is equal to C1 into 6. 6 is the potential difference across C1, and the value of C1 is 4. So it should be 4 into 6, 24 microcoulomb. And similarly 9 volt across 1 microfarad and 3 microfarad, potential difference should be V2, means 9 volt. So across 1 microfarad capacitor, potential difference should be 9 volt. So we can calculate Q across, we can take it Q1, we can take it Q2, Q2 across C2, it should be C2 into 9, and value of C2 is 1. Value of C2 is 1. So we may write it 1 into 9, and it becomes 9 microcoulomb. And we can see that in the circuit there is a charge of 24 microcoulomb, and charge is flowing in this direction, but charge across this capacitor is only 9 microcoulomb. It means remaining charge is moving in this direction, and this is C and this is D. It means the remaining charge 24 minus 9, 24 minus charge is moving in this direction C to D, and the charge which is moving C to D, it should be Q is equal to Q1 minus Q2, 24 minus 9, 15 microcoulomb charge is moving towards C to D. So the answer of this question is 15 microcoulomb C to D. So this is the answer of this question. So thank you, and similar problem we will discuss in next video. Thank you very much.